Hello viewers, welcome back to my channel, and in this video we are going to talk about how to solve first order linear differential equation. In my previous video we learned about how to prove for integrating factor and also how to find integrating factor for differential equation when given. So now let's quickly go straight to what we have today. Kindly press the subscribe button if you haven't subscribed. So first order linear differential equation is always represented in the form dy over dt plus p of t multiplying y is equal to g of t. We said there is an assumed function called the integrating factor mu of t, which always when you multiply it by the p of t, it gives us the derivative mu prime of t. It's an assumption you make. So always to solve the first order linear differential equation, what you are going to do is that you find your integrating factor. In the previous video we saw that integrating factor mu prime of t is always equal to k multiplying e to the power integral of p of t, but we don't bring the k when you are finding the integrating factor. So now let's move straight to solve this first order linear differential equation. What you are supposed to do is that you multiply every term of the equation by the integrating factor mu of t. So we are going to have mu of t multiplying dy over dt plus mu of t multiplying p of t y is equal to mu of t multiplying g of t nicely. So from here we said when you multiply this by this function, you always get the derivative of mu of t. So we further write mu of t dy over dt plus mu prime of t y is equal to mu of t then g of t. Now at this point we know that if you have mu of t dy over dt plus mu prime is the same as the product rule. So this is also equal to mu prime of t multiplying y all prime. From the product rule you will differentiate this as the y, we maintain the u of t. Here we differentiate this and maintain the y. So this is equal to mu of t g of t. We want to find y. That is the aim of differential equation. You have to make y the subject. So we take integral on both sides. Integral of mu of t y all prime integral of mu of t g of t. So at this point this will nullify the derivative here. We get mu of t then y plus c is equal to integral of mu of t g of t. We move our c here, we get our mu of t y to be equal to integral of mu of t g of t minus c. So at this point to find y, what do? We make y the subject. So our y becomes mu integral of mu of t g of t minus c all over mu of t. So this is the general form of our solution for our solution finding the first order linear differential equation to solve it. So y is equal to the integral of mu prime and mu of t multiplied by g of t minus c all over mu of t. So now let's see. We know that our mu of t is the same as k e to the power integral of p of t. So our expression can further be simplified to mu of t g of t minus c all over k e to the power integral of p of t. Now k and this will separate, they are constants. So mu of t g of t, we have minus c on k all over e integral of p of t. So this also c over k, they are all constants, so you can represent them with just a single constant, and our final solution becomes integral of mu of t g of t minus k all over e to the power integral of p of t. So this is a general solution of how we can solve a first order linear differential equation. Thanks for watching. Kindly subscribe so that as I will post several problems, you will learn how to solve the first order linear differential equation for different types of equations. So follow, subscribe, like, so that you get notified when I post problems or solve problems. Thank you.